So the final, I mean, today's review is for students who come to the class only. So I won't share the slides to Moodle. So yeah, you sorry? No, I won't. Yeah. Yeah, you can. Yeah. So basically, I mean, we learn all these chapters, but because we have already kind of do a midterm exam for the previous chapter, so the final exam mainly focused on these three chapters. Of course, we will have like maybe one or two questions for these previous chapters, but don't worry about that. And so let's see. I mean, recursion. Actually, we have already did a lot of questions about recursion. So I will not spend a lot of time on it today. So this question we've solved it previously, right? It's just I mean the answer is A. It's because factorial need to return that base statement. So the total times is just the n plus one. And second, generics is a very good function in Java. It can detect errors at compile time and make programs more robust. And also, I mean, it can avoid cumbersome castings and it won't affect the speed of the program. So this question, number D, is not correct. Then we learned the stacks and list, queues, all these different data structures, and they all have their special features. For this question, which of the following statements are true? It's A, right? Because we know priority queue, it orders its element based on the comparator. And it can be changed as long as you override the comparator method. And it cannot also be reversed. It has a reverse method can do that thing. So for these questions, the first one is true. How about this one? Like, suppose list is a linked list and contains 1 million int values. What is the time complexity of get? It's O(n), right? This one, because a linked list, if it's get by index, it will be kind of, you need to traverse to that specific location and then get that element. So this one will be O(n). And at first will be O1 because you just add a new node as like the head node on the linked list. And at E, this one is a little bit tricky because it is also add a new node to the list, but it's at E instead of at first or at index. So it kind of, you can just add that node at the very end of the linked list. So the running time of this one would be O1. So we learned set and maps. We know like a set just store non-duplicate elements, and map is just a dictionary. It has a key, and each key has a value. So for this example, what do you think? Like after this 4 put statements, what is a value that corresponds to key 1, 2, 3? Yeah, it's Steve Yao, right? Because like kind of each key can only correspond to one value. Here we put key to John Smith, but we put again key to Steve Yao. So it's kind of John Steve Smith is replaced by Steve Yao. So this one will be Steve Yao is a correct answer. We then learned how to develop efficient algorithms, basically how to use a big O notation to represent the time complexity and the space complexity of the algorithms. We also learned that there are many typical functions to represent the time complexity, and O1 is constant time, and O(n) is linear time. So for an input that results in the longest execution time, what does that input usually call? It's a worst case input, right? We know like we use worst case input to determine the time complexity of an algorithm. And what is the time complexity of the following computation? So the first one, we know we can remove the multiplicative part and remove the non-dominant part. So the first one will just be O(n) squared. Second one, this one is larger, so O(n) log n. And the third one, similarly, n squared. We can just remove the non-dominant part. Yeah. And this question actually is a very good question proposed by a student. So which is the following statement correct about for each loop and iterator? So the correct answer is A. It's kind of, I mean, iterator, the very special about it is it provides a way to remove elements safely while iterating. Kind of you can do a loop using iterator and at the same time just remove the element. It won't cause any issues. But if it's for each, or if you just using an index to remove the element, because once you remove the list or the stack, their space will be decreased, and which may cause some issue. So the most difference about iterator and the for each is just the iterator has these special features. It can safely remove elements. We then learn all these different sorting algorithms, and we know that we also explain their time complexity. For example, we know quick sort is n log n, bubble sort is O(n) squared. But we actually didn't talk too much about this on class. I don't know if you still remember this. What is the best time complexity for insertion sort? So we don't talk about best time complexity because we only consider about the worst time complexity. But the thing is, the best time complexity is just O(n). That's because if this list is already sorted, I mean, we don't need to do any insertion or any moving. So we kind of just the insertion algorithm just start from the beginning, check every element, and know, okay, it's correct, and then just move to the end. The sorting would just become like a traverse of this whole list. So the best time complexity for, actually, I think for every algorithm is best, sorting algorithm is best time complexity is always O(n). It's kind of just, it's already sorted. You don't need to do it, just traverse the list. So next question, which of the following statements are not true? This one actually is a question to test your understand about heap. We know heap is a complete binary tree, and also this one is also true. Every node is greater than or equal to its children, and it's complete if there's is full and all the leaves on the left side. So this one, number D, is incorrect. It's called complete binary tree instead. I mean, there's no such kind of idea, full binary tree. So another question, on average, if an element is in the list, linear searches, the correct answer is B, half of the tree. It's kind of like you can, the number you want to search, it can be at the beginning or at the end. So on average, it's just n divided by 2. Next question, in quicksort, what is the correct about a pivot? So we know that the pivot, it can divide, we use a pivot to divide the list to sublists, right? Left one smaller, right one number longer. But in our course, we use the first number as pivot, but actually the second one is correct. A pivot can be chosen arbitrarily. You can use any number in the list to divide the list as a pivot. And because this pivot is not like the what is that? Binary. It's not like the binary search, right? Binary search, we just we compare the one in the middle each time. It's like a same size. But for quicksort, this pivot is just divided to smaller size. It doesn't have to be equal size. So this one, the correct answer is B. And also this idea. So remember this algorithm we discussed in the class. In the final exam, we will have a question about using this algorithm to partition this list into, I mean, like a first step. For example, choosing 65 as a pivot, what will be the list after the first round of the partition? And this algorithm is using O1 space complexity. It's very convenient and also very like commonly used in many implementations. So if you are not familiar with it, please check this tutorial again. And also you can ask me about it and make sure you understand it. We will have a question to ask how that works. Yeah. Um, Next one, we chapter 24, we learned how to implement list stack queues using array list and linked list. So for this question, my array list is more efficient than linked list for which of the operations? The correct answer is D, none of the above, because both insertion and deletion actually linked list is usually better. And this one append an element at the end of the list. So this one for both array list and linked list, their time complexity is the same. So this question is none of the above. We then learn binary search tree today, and we know like there are many traverse methods. So this question, what is which method visit node level by level? First root, then all the children of the root, and then grandchildren start from left to right. It's a breadth first traverse, right? We just talk about today. It's just um, a master that traverse the whole list level by level, whole tree level by level. So in our final exam, we will have 10 fill the blanks questions. This is a sample, like an example question. So we will have a list, and after the first pass of the bubble sort, what the list becomes. It's kind of, we just need to read them one by one, right? This one, we don't swap them. This one, we need to replace 4 and 9, and then replace 9 and 7, replace 8 and 9, replace 2 and 9. And that's how, after the first pass, what the list becomes. And another one, this one, we talked about it last week, like how to use linked list to implement the add first method. So the idea is we have we need to create that. Thank you. We need to create that node. We have a head node, right? And we need to add the new node before the head. The thing is, this just create one node, and this node is next would be the head, right? And then after that, we can mark this one as a new head. So this question will be create a new node, and new node next equals head equals to new node. Yeah, that's kind of like how the fill the blank questions will look like. You just need to fill the missing part. Yeah, yeah, that's all about the example questions. Um, any questions about this? Yeah. Then yeah, that's it. Sorry, you're late. Yeah, if you can, if you want to check, I can show it to you again.
Could you show me the first question?
Yeah.
Thank you so much.
Like something about priority queue. Yeah, and then we like how to determine the time complexity of these operations, like this one, O1, 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 and also this one, how to do map function, this one, like because each k only correspond to one value, so it will be stbiao. And also,
Could you take a picture of the map?
yeah, you can, yeah.
Thank you.
And also, like what each of these, like you already called, like this one constant, this one linear time, and also the worst case input is one like results the longest execution time, right? Yeah, and also you need to know how to like what is the time complexity of the different equations, and also the difference between iterator and for each is that iterator can safely remove elements. And also, we know the time complexity of these algorithms, sorting algorithms, and the best time complexity for insertion sort is O(n), because that's kind of the list is already sorted and you just need to reverse the list. And we know a heap is a special data structure, it's a complete binary tree instead of full binary tree. This one is not correct. And on average, if an element is in the list, you just search half of the list, right? And the pivot is just a number in the quick sort in the list. You can just choose it arbitrarily. It doesn't have to be like the one divides the list evenly. And yeah, and also we talk about like we talk about the binary search tree today, and there are some traverse method. The one search level by level is called breadth first search. And like this one, you might already saw it. It's yeah, kind of like the example to the yeah. That's